Guys, so I thought I can solve the following questions that we didn't get to solve in the class. So we're all on the same page. So question 26, Pepsi promotion. So in this question, we have a sales promotion going on, and the manufacturer places winning symbols under the caps of 10% of all Pepsi bottles at random. Now, if you buy a six-pack of Pepsi, what is the probability that you're gonna win something? So the first thing that we need to pay attention to is that probability of winning for a single bottle is 0.1 or 10%. Now, if you buy a six-pack, winning in a six-pack, this would be equal to probability of 1 minus probability of no win in all six. Okay, because if you could win one, you could win two, you could win three, four, five, six. But going through all of them one by one is difficult. So we're gonna look at the case that we don't win anything and find the complement of that. So probability of not winning would be 0.9. So this would be equal to 1 minus 0.9 times 0.9 times 0.9. Okay, so this means none of these guys are winning. Or I can write this much more simpler like this. Let me see if I have the number for that. This is equal to it's in something like this. Okay, so pretty simple. Next question. So in the next question, a tire manufacturer recently announced a recall because 2% of its tires are defective. If you just bought a new set of 4 tires from this manufacturer, what is the probability that at least one of your new tires is defective? So, let's see. So probability of a tire being defective is 2%. Now you bought a set of 4 tires. What is the probability that at least one tire is defective? Now this is equal to 1 minus probability of no tires being defective. So probability of not defective for one tire would be 0.98. So this is 0.98 to the power of 4. So this means none of the four tires are defective. So all good. The next question that we have was about probability trees. So okay, so example 1 about the extended warranties. So in this question, we are looking at a company that manufactures and sells consumer video cameras. They have 2 popular versions. One of them is a basic one, and the other one is a deluxe version. Basic is $750, and the deluxe version is $1,250. Now, 75% of consumers select the basic camera, and out of those, 60% purchased the extended warranty for an additional $200. Of the people who buy the deluxe version, 90% purchased the extended warranty. Okay, so we want to first create a probability tree for this. Okay, so let's see how we're gonna do that. So first of all, I have two different options. I could buy a deluxe camera. Let me put the basic first. I can buy a basic camera, or I could buy a deluxe camera. Now, the probability for deluxe is 75%. So this means probability of basic is 75%. That's gonna make the deluxe 25%. Now, out of people who purchase the basic, 60% purchase the extended warranty. So that's gonna make 40% who don't purchase the extended warranty. And for the people with the deluxe version, 90% will buy the extended warranty and 10% do not buy the extended warranty. Okay, so this is gonna be our tree, our probability tree. And then to compute the joint probabilities, we're just gonna multiply the values on each of the branches. So this guy would be 0.75 times 0.6, 0.75 times 0.4, 0.9, 0.25 times 0.1. And 0.025 for the last one. So this is our joint probabilities. Now, in the next section, we want to create a joint probability table using this information. Okay, so create a joint probability table. Now, in this next sheet, I have my probability tree tidy, and we can use that to create our joint probability table. Okay, so now let me first complete what I know already exists. That's going to be my overall total, which is equal to 1. Then I can compute my joint probabilities. Okay. So first of all, basic and extended warranty is 0.45. Basic and no extended warranty is 0.3. That's going to make my entire basic 0.75. Okay, I could alternatively just use these ones, 0.71 for basic and 0.21 for deluxe. But I have all the details, so why not? Now for deluxe, I have 0.225 for the extended warranty, 0.025 for no extended warranty. And then I'm going to add up the values for every column. That's going to give me 0.675. These are who opted for extended warranty. And I'm going to have 0.325 for those who are not going to have an extended warranty. Okay, now we are ready to answer rest of the questions. So this one is asking me, what is the percentage of customers who purchase an extended warranty? Guess what? This is our marginal probability. Okay, so let's go back to our table. So in this joint probability table, this is all the people who are purchasing the extended warranty, 0.675. I could also look at my tree, and then these guys, and also these guys are those who are purchasing the extended warranty. So I would just add up these probabilities. So this would make it 67.5%. Given that a customer purchases an extended warranty, what is the probability that he or she bought the deluxe version? So let me answer this here. Given that they bought the extended warranty, what is the probability that they purchased the deluxe version? So on the denominator, I'm gonna have probability of extended warranty, and in my nominator, I'm gonna have the probability of deluxe and extended warranty. Now, probability of extended warranty was 0.675, and deluxe and extended warranty was 0.225. So I'm gonna use 0.225 to compute this probability. Okay, now the next step is to compute the expected revenue of the company from purchasing a camera, including also their warranty. Okay, so let's go to our probability tree. So if I purchase a basic camera, that's gonna cost me 750. And when I'm on this branch, on this first branch, I'm also gonna purchase a warranty. Now, when I'm on this branch, I'm not gonna buy a warranty, and I only have the cost of my basic camera. And for the other two branches, so for this branch, I'm gonna have cost of my deluxe camera and 200 cost of my warranty. And on the last branch is only gonna be the cost of my camera. And to compute the expected revenue, I'm gonna need to multiply probabilities by revenue for each of these. So these are different scenarios, and we have the revenue that we're going to get from different scenarios. And we're just going to need to multiply them by their probability. So I don't have a space to compute this, but you can just simplify this using a calculator. I think it should be $10,010.